Hi, you're watching the Completing the Square Notes video. This topic is actually a really important topic that we will use both during this unit and the quadratics unit. But for now, we're just going to practice this concept and we're going to make some connections and hopefully learn some really valuable skills to help us next unit. Number one, the first thing that we need to do is simplify x minus 11 all squared. So if we remember and recall how to do this, this is where we're going to set up the box method, and then we're going to look at x minus 11 all times x minus 11. Because remember, x minus 11 squared really is the same thing as x minus 11 all times x minus 11. If we do this and multiply it through, we get x squared minus 11x minus 11x plus 121. If we group our like terms together, we get negative 22x. So that was fun. X squared minus 22x plus 121. Well, if you notice a couple of things, 11 times 11 is 121, or negative 11 times negative 11 is positive 121, and negative 11 plus negative 11 is negative 22. So I want you to look at number 2, and when we factor this, we're going to use the box, but remember we use it in a different way. So when we use the box in a different way, we go backwards. So we put the x squared here, the positive 16 there, and the positive 8x here. X times x is x squared, and we have a few numbers that add to 16, but we're kind of trying to establish like this concept of the same number being used as part of the factors. Like in example number 1, we had minus 11 and minus 11. So let's think here. What times what will give us 16 but add to 8 and be the same number? If you said positive 4 and positive 4, you, my friends, are correct. So this factors to be x plus 4 all times x plus 4. And what makes this so special? Well, the factors, or the binomial factors, have the same number in them. So that's something that's important to us. We're actually going to use this to help us with question number 3. So there's a game. Not really. I mean, it's a math game, so you can decide whether or not this is fun. I think it's fun. So what we're trying to do, or what we're going to try to do, is we're going to try to find this number here given this number here. So what we are going to try to do is find two numbers that add to 12 that are the same. So what two numbers that add to 12 are the same? If you said 6 and 6, you are correct. So if you think about what was happening here, 4 plus 4 was 8, and then how did we get this 16 here? Oh, we multiplied 4 times 4. Okay, so what is 6 times 6? That would be 36. Okay, part B, let's do the same thing. All right, what number plus itself is 14? If you said 7, you're correct. And let's do 7 times 7, and that gives us 49. So up top here, we did 6 times 6. It was almost like we took half of the number and then multiplied it by itself. That was weird. Okay, let's see if that works for part C. So what number plus itself is negative 20? If you said negative 10, you're right. So let's just multiply negative 10 times negative 10. It's positive 100. All right, negative 6. Well, what's half of negative 6? Well, negative 3 plus negative 3 is negative 6. So what's negative 3 times negative 3? That is 9. All right, so this piece here is helping us complete the square. So if you think about a square has two sides that are the same. Okay, so that's exactly what we're doing here. Let's see how this looks when we're given a trinomial. Well, when you first look at this, you might think to yourself, oh, well, what we were doing above, we were taking half of this number and then we were multiplying it by itself. So like if we did that, that would be 3 times 3. So we want this number to be 9, but it's actually 17. So right away, we're realizing that there's a problem. So what I always like to do is I like to move this 17 off to the side. okay? Because he's in the way. But what we just talked about above was we took half of this number, right? We took half of that number, which is 3, and then we squared it. So 3 times 3 is 9. So this would be plus 9. But here's the problem. We can't just randomly add 9 to an expression and expect not to change the value. We did. So the only way that we can cancel out adding 9 is to actually make adding 9 0 somehow. So what can we subtract from 9 to make it 0? Or, I just gave it away. What can we subtract? Well, maybe. What can we subtract from 9 to make it 0? I don't think I actually gave it away, but if you're thinking 9, you're correct. 9 minus 9 will equal 0. Okay, so what is this here factored? So if we write this as a binomial times a binomial, x times x gives us x squared, and 3 times 3 is 9, and 3 plus 3, that would have been the two corners of the box. That would give us x plus 3 all times x plus 3. And then we kind of have this leftover business here, 17 minus 9, which is positive 8. So I'm just going to write that as plus 8. And the last and final piece is that we can take x plus 3 and square it plus 8, because x plus 3 all times x plus 3 is x plus 3 all squared. This portion here, question number 4, might be a nice part to watch and rewind if you didn't follow, or you're like, wait a minute, what did she just do? But we're going to do so much more practice with completing the square in class.